Hey, Peyton. So I just wanted to bring up one thing that I know that we didn't do yesterday before I answer these questions on the page in that picture up top. So if you look right here at my angle A, B, C, or remember we can call it C, B, A. If I had a line that came through angle ABC and it went like this, and we're going to call that D. Okay, so what I'm wanting the line to do is basically take angle A, B, C and cut it in half, which would mean then this angle right here and this angle right here would be equal to each other. Okay, so if they're equal to each other, usually what I'll do, or what we do, I should say, is we go like this and then we go like this. And when we see two little curvy things here with the same number of curvy things, that means that these two angles are equal. Now, maybe that doesn't make sense to you, so hold on, let me show you something else. So here I am now over here, same angle, okay? But what if this time I take from B, I come out like this, and D is kind of down there. Do you see that this angle right here wouldn't be equal to this angle right here, right? This one would be bigger than this one. So I'm going to go back to this first picture over here. When they're equal to each other, we write it like that. I'm going to show you what we do if they're not equal to each other. So like I'd put maybe one curvy thing here, but then I put two here. And what that's basically showing is this one is not the same as this one. So when I have the same amount of curvy things, then we say, oh, those two are equal. When we don't have the same amount of curvy things, that means they're not equal. Okay, so if you know that angles are not equal, don't do this. I'm going to repeat what I just said. If you know that two angles aren't equal, don't do this, because this is saying they are. This is saying they aren't. Got it? Alrighty, so if you look at the picture for number 3, I read this right here, and then I just put the values right in there. Okay, so they said that KJM, so remember KJM, so that's this angle here. J is the vertex or the center, but we call it the vertex. But look, from K to J, now we're kind of making a right-hand turn here and going to M. So this is 22. And then this one is KJL. So we're starting again with K to J, but then we're making a left up turn. So this piece is 84. Okay, so then what they want is they want you to find the measure. This means the measure of angle MJL. Okay, so in other words, how many degrees is it? That's all this little m means. I honestly usually ignore it. Okay, so here we go. So we got MJL. So let me see how good I am here at highlighting. So this, whoops, how bad was that? All right, let's try that again. So this is the angle that they want you to find, right? MJL. Okay, so if you hopefully can see that MJL is these two angles together. So all I really have to do then to find angle MJL is to just add 84 plus 22. Okay, and then when I get that, that is going to give me the measure. Now, if you forget that little m, nobody's going to mark off for it, so don't worry about it, of angle MJL. And that would be what, 106? And there's your answer. Okay, so just make sure that you're taking notes and you're putting this in your packet as we go along, okay? Okay, so now for part B, if you look at that one, it says LJM is 145 degrees. So let's look at that, LJM. That's this whole big angle here. So what I'm gonna do is I'm gonna go like this. This whole big angle here, I'm exaggerating a little bit, is 145 degrees. That's the whole big thing. Now let's look at the second part here. Okay, so then it's saying KJM is 48. So let's find KJM. Okay, let me do that in a different color just so that you can see it. So KJM is this little piece right here, and that is 48 degrees. All right, so now let's look at what they're asking. They're asking you to find the measure of angle LJK. So let's find that one, LJK. So they want this piece. So you're pretty smart. I think you could probably figure it out. This whole thing is 145. This piece is 48, and they want this one right here. Okay, so what I'll do is they are looking for this piece right here. Do you see that the blue plus the red equals 145? So all you have to do to find the measure of angle LJK is to take your 145 and then you're going to subtract 48 from it. And that will give you the measure of angle LJK. All right, so take a second and work that. All right, and you should have 97 degrees. Okay, look at number 4. See if maybe you can answer this question. And so what you want to do is just pause the video. And I want you to kind of do what we did up here where, you know, I put numbers in their appropriate spots and then see if you can answer the question. And then unpause me and see if you're right. Okay, all right, so I'm going to just kind of go through it step by step. So they gave us the whole angle here is 158, and this little piece here is 64. Now, you know how I put these little curvy thingies? You can put them or not, okay? You're going to see as you get further on into the course, there are times where you're definitely going to want to put them, but here, it's up to you. You can do it or not. Now, here's the really interesting thing. So GEH, so GEH, that's this angle right here and this space, okay, is equal to HEI. So I'm actually going to put the curvy things there just so I know that they're the same. So this one is the same as this one, but we don't know what they are. And so it says to determine the measure, let me just go over here, the measure of angle FEH. So FEH. Okay, so, well, how about this? How about we figure out what these are first? If you know the whole thing is 158, wouldn't that mean that this plus this plus this should equal 158, right? That's one way to do it. So, but I don't know what these are. So if you're pretty good algebraically speaking, then what I would maybe do is just say, all right, I don't know what something is. I'm going to call it X. Okay, and they're both the same, so they would both be X, wouldn't they? So we can do this one of two ways. We can say X plus 64, I know together, will give me 158 degrees. So let's just do good old-fashioned algebra. X plus X is 2X plus 64 equals 158. Then I would subtract 64. Okay, and I would get 2x equals 94, and then I would divide out my 2 from both sides, and I would get x equals, what do I got here? So this would be 4, obviously you have a calculator, I'm doing it in my head, 47, right? So then I know that this red piece is 47, and this red piece is 47. Now, that does not answer the question, but we need it to answer the question. So look, because it says, I'm going to go back to this, determine the degree measure of FEH. All right, let me go to my highlighter here. Let me find my highlighter. There we go. All right, so FEH is this space in here. Okay, well, hopefully you can see it, and I'm sure you can at this point, that it's just 64 and 47 added up. And that will give me the measure of angle FEH. Okay, so let me go back to my pen here. So angle FEH equals, I'm just going to do the work right over here, 64 plus 47. Again, you're putting this in the calculator, but 11, what do we got there? 10, 111, right? 111 degrees. Okay? Now, again, you should be taking notes. If you don't understand this, take the notes anyway. You can always pause the video, rewind it, and watch it again. But I'm going to see you on Monday so I can go over anything that you don't understand. Okay, last one on this page. So I'm looking at number 5. So I just, I read what it said to do here. So I did that over here. And then I just labeled what these are. So ACD, so ACD, this whole angle here is 153. And then BCA, so I started here B, I went to C and A, that's 98. And then they want to know what BCD is. So B, C, D. So I did the little archy things. It's up to you. And I called this X because I don't know what it is. Now, I'm curious if you know how to figure this question out. This is a little tricky or different, but so the deal is just, I'm going to start here. Watch my arrow. You ready? I go like this, I go like this, I go like this, and I come back around. What did I just draw? Okay, I mean, again, I do know it is just with my pointer, but follow it again. What am I tracing? I'm tracing a circle. Now, you should have learned that a circle has 360 degrees. So this piece right here, along with this and this, should add up to 360 degrees. Here's where your algebra comes in. Okay, so kind of like what we did in number 4 up here. Okay, I kind of set up an algebraic equation. Oh, let me back up though. Number 4 up here, if you figured this answer out and you didn't do all this like fancy algebra, that's totally okay. Some kids will be like, oh, all right, I'm going to take 158. I'm going to subtract 64 from it, and I'm going to get 94, and then I have to cut 94 into 2 equal parts. That's exactly what I did here. I just did it a little bit more algebraically. If you do it non-algebraically, it is totally fine. As long as you're showing work, it doesn't matter. I'm going to do this algebraically. So I'm going to do x plus 153 plus 98 equals, and a full circle around is 360. All right, so now why don't you pause me, finish this, and let's see what you get. Okay, and there's your answer, 109 degrees. Okay. Now, part C says to explain how you found your answer to part B. Well, we kind of have the work already up here. If you had to write words, you could just say, I know that there's a full circle around here. So 153 plus 98, if I add them up, I get 251. And then that remaining piece I would get by subtracting the 251 from 360. But to be honest with you, I think this is sufficient. I'm just telling you. All right. Okay, I think that this one will go pretty quickly, this page. You and I were talking about this yesterday. So an acute, you're going to need to memorize this. An acute angle is always going to be an angle that's between 0 and 90 degrees. Okay. An obtuse angle is going to be an angle that's between 90 and 180 degrees. A right angle is an angle that measures 90 degrees. And a straight angle, this is what you said to me yesterday. Straight, maybe you didn't call it a straight angle, but you knew what it was. Where is it? Here we go. Measures 180 degrees. Now we have this thing called a reflex angle. You're not going to see it all that much, but just FYI, that's between 180 and 360. Okay, so just in case you're kind of not totally following here. So this is the one that you were talking about yesterday. This is a straight angle. It's a straight line. So that's 180 degrees. Okay, so I'm going to write straight right here. And you should do the same thing just so you have this in your notes. Straight angle. Okay, now I kind of wish, I don't really love this picture. I think they mean for this to be a right angle. To be completely honest with you, it doesn't look it to me, but okay. A right angle is basically like an L or a T. Okay, so for example, if I have a perfect L, which that is not, I'm going to have a right angle here. Do you recall maybe ever seeing like a little box there? Or if you have a T like that, okay, that's a right angle. Well, by the way, so is this one, so is this one, and so is this one. But so I think that they mean for this guy right here to be the right angle. And you tend to see a box to designate a right angle, and that's 90 degrees exactly. Okay, so again, straight angle is 180. A right angle is 90. So this is 90 degrees, and this is 180. Okay, then we got everything else, and I'm kind of going out of order for a reason. All right, so I'm going to go to this guy right here. Well, this guy, if you look at this space right here, it's definitely smaller than this space right here. Okay, so that's what this is called your acute angle. Okay, and an acute angle, again, you can read up here, is between 0 and 90 degrees. Okay, so an acute angle is less than 90. All righty, then I'm going to go over to this guy here. All right, so this guy is called an obtuse angle. So an obtuse angle is something that's bigger than 90. See how this is bigger than 90? Okay, however, it's less than 180. So it's like between these two guys. Okay, so an obtuse angle is between 90 and 180, as you can kind of read up above. All right, so then we've got this reflex angle here. So I wish I could kind of show you in person, and I can't. I'm kind of limited with the video here, but a reflex angle is something that, like, pretend if you could sort of, and I'm going to dot this just so you can see it. If I were to take this line and just continue it on like that, okay, you can see, here we go, that this is 180 degrees, right? If I start here and I go around like that, that's 180. But we're going further, kind of like a clock, right? If I go from 3 o'clock, not that we would do this, but pretend I'm going to 3 o'clock, then I'm going to the 12, then I'm going back to the 9. But then if I keep going back this way, I'm going even further. So I'm going further than my 180 degrees. That's a reflex angle. You will see it. You won't see it a lot. Okay, I'm not really sure if I have the pages in the correct order here. So my apologies. I didn't take pictures of the page numbers. But anyway, whatever page this is, here's your answers. I think that you would figure these out pretty quickly. And then here, don't worry about using your protractor. Don't worry about that at all. So it just says use a 3-letter system to name the angles and then classify them. So this one, I did M-A-N as my angle. Don't forget the angle symbol. If you did N-A-M, that's also okay. The A has to be in the middle because that's the vertex, that middle part. But you can what's the word I'm looking for? You can switch those around, okay? And this is an acute angle. Then if I go to B over here, P-D-O, you could have also, that's how I named it, angle PDO. You could have said angle O-D-P. That's also okay. The D is the vertex. It has to stay in the middle. And this is a right angle. Okay, this guy here, I just went from left to right. So I did angle QGR. Again, you could do angle RGQ, and it's a straight angle because it's a straight line. And the last one, I went SJT. You could have done angle TJS, and that's obtuse. Okay, and for exercise number 2, there are your answers. And again, if you want to change these guys around, the V is the vertex though, it's got to stay in the middle. Same thing with O, and the same thing with A, but you can, you can change the C and the T and the U and the Y. All right, so here's where we start doing some real-time geometry here. So if you look at exercise number 3, they told you that angle WRV is 3x plus 22, and angle XRV is 2x minus 12. Now, I kind of don't love that they went like this, because to me, for a quick second there, I'm like, oh, does that mean that those are equal? No. Look at the picture. I know pictures are not usually always drawn to scale, But to me, clearly this one looks obtuse and this one looks acute. Okay, so be very careful with that. So I would not say, oh, they're equal to each other, but I do know, let's take my little analogy with the clock from before. If I start here and I open up to here, right, I get that first angle. And then I keep going to here. Do you see what I've done? Let me put it in a different color so you can see it maybe. There's my first angle. And then I keep going. Do you see that that's 180 degrees? What I just traced in red is 180 degrees. So what I'm going to do is I'm going to take that, hold on, let me put this in black so you can see it better. I'm going to take my 3x plus 22 and I'm going to add it to my 2x minus 12. And I know those angles together will add up to 180 degrees. Okay, and now the rest is good old-fashioned algebra. So 3x plus 2x I know is 5x, and 22 minus 12 I know will be 10 equals 180. So then I'm going to subtract that 10 over, which is going to give me 5x equals 170, and then I'm going to divide out that 5. Okay, and then I'm going to run out of room here. I'm going to squeeze it in here. X equals, and then you can just throw this into your calculator, and it should be 1534, right? Okay, but let's be very, very careful. So a lot of kids will be like, oh, okay, done. No, not done. And here's why. The question says, find the numerical values for angle VRX and WRV. So they want to know how many degrees is this, and how many degrees is that, okay? So essentially, they want what I just wrote right over to the side right here. But look, we know that x is 34. So can't I just put a 34 here and a 34 here, and then I'm good to go, right? All right, so actually, let me just do this. Let me go back just so I give myself a little bit more room. So let's take that 3x plus, it was 22, right? And I know that x is 34, so I'm going to do 3 times 34 plus 22. And just put that in your calculator, and you will find out how much angle, what is that one? That one is angle VRX, right? So angle VRX equals. All right, so I'm going to take my calculator. I'm going to do 3 times 34, and then I'm going to add 22 to it. And that is 124 degrees. Okay, and so there's the answer to the first question that they asked us. All right, now they also wanted the measure of angle WRV, which is the 2x minus 12, right? And again, we know that x is 34. So I'm just going to do that. Oops, make that a minus sign, minus 12. And I'm going to do that in my calculator. So 2 times 34. Okay, and then I'm going to subtract 12, and I get 56 degrees. So that means angle WRV equals 56 degrees. And there's your answer for exercise number 3. Alrighty, so for exercise 4, I'd actually like you to pause the video and try it yourself, because I think you really could do this. And then you can unpause and see if you got the answer right. Okay, is that what you got for part A? Hopefully, because it says that NMQ right up here is a right angle. So that means that you should know, see that box right there, right? That this whole thing is 90 degrees. So if this piece of it is 42, then I know 42 plus something would add up to 90, right? Or 90 minus 42, and there's your answer, is 48. Okay, thing for part B. Okay, so I want you to pause the video and try that one. Okay, now this one's a little trickier. If you're a good problem solver, you might have been able to get this one. So let me see. It says NMP right here is twice PMQ. So NMP, this guy here is double whatever this guy is. But they have to add up to 90, right? So you could just kind of like make stuff up. So for example, I'm totally going to make this up. I would think of a number and then double it. So like, let's say I think of a number and that's 20. If I double that, that would mean this guy is 40, right? Okay, but do 20 and 40 add up to 90? No, they don't. So then I would be like, all right, well, that's not the answer. So let me try something else. All right, so I tried 20, right? That didn't work. So let me try 30. So if this is 30, I double that, that's 60. And do these two add up to 90? Bing, 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 bing. Yes, they do. So there's your answer. Now, if you're looking for a more algebraic way of doing it, I'm just going to show you real fast. Okay, and it's up to you whether you choose to do it this way or not. If N and P is double the other guy, and I don't know either of them, I would say that's X. And then double that is 2X. So then I would just do 2X plus X, those together would equal 90. Then I add 2X and X and I get 3X equals 90. I would divide out the 3, right? And that would give me 30. And there is the first angle. And then if I want 2X, what I'm doing is I'm taking my X equals 30 and I'm putting it in here and doing 2 times 30. And then 2 times 30 is 60. And that's how I got that. Okay? It's really up to you. I am going to tell you, if you could reason it out like I did the first way, totally okay. However, you are going to get to stuff. And so this is really going to be important. So you just kind of want to try to lean toward that as we get into some harder questions. All righty, so number 4, they gave you what X was. So I'm just going to take that 4 and I'm going to take that X and put 15 in there. And I'm going to add 12 to it, and I'm going to just figure this out. So 4 times 15 is 60 plus 12, so that's 72. And they want to know, this is a measure of angle A, is that acute, obtuse, or right? And it would be acute because it's less than 90 degrees. Okay, all right, let's look at number 5. It says that EHG is a right angle. So EHG, that means this whole thing is 90 degrees. Now EHF is X plus 1, and GHF is 5X plus 5. So now remember how I said on the last page that, you're going to get to things where you're really going to have to do them algebraically. Here we go. All right, so I know that those two angles, the 5x plus 5 and the x plus 1, add up to a total of 90 degrees. So now I'm just going to do some algebra. 5x plus x is 6x. 5 plus 1 is 6 equals 90. I'm going to subtract the 6. Okay, and that's going to give me 6x equals 84, right? You do it in the calculator if you're not sure. Divide by 6, divide by 6. So I have x equals 14. Now, please make sure that you read the directions because sometimes that's not what it's asking for, but let's read it. It says find the value of x, bingo. Ooh, but it also says the numerical values of EHF, so that would be this, and GHF, and that would be this. Okay. So we got this. We already know, this is the hard part right here. So basically what they want to know is what's x plus 1? Well, if x is 14, right, wouldn't I just put a 14 right in here? Plus 1 would give me 15. Okay, so there's another answer. And then they also, and by the way, that I'm being lazy, that would be the measure of angle EHF. Then if I wanted GHF, I would just figure out what 5x plus 5 is, right? This is going to be for GHF. And I'm just going to do 5 times 14 plus 5. And again, I do it in the calculator. So we just do 5 times 14, and then I'm going to add 5 to it. Okay, and so that's going to be 75. And there's your 3 answers. All right, I'm almost done with the torture. 6, I don't really want to do, to be honest with you, this whole chart. It's a little confusing, but down here, I'm going to apply this picture to what they're talking about down here, because this is very important. Okay, so I'm going to highlight this. Vertical angles. They share a vertex, and their rays point in opposite directions. I don't love that explanation, but basically, here's what they mean by that is, let me get my pointer. I think it'll be easier. All right, a vertical angle. So you basically have 2 lines here, and they intersect at E, meaning that they cross, right? Can you see that G, E, H, right? It kind of forms a V, right? And then opposite this angle is FEM. Okay, so I'm going to mark them in one color. This angle here and this angle here. It's kind of like a bow tie in a sense, right? This would kind of be the knot, and then, you know, your bow would come off in that direction. These are called vertical angles. So that's what they meant by rays pointing in opposite directions. They share a vertex, meaning that right here is the vertex E is the vertex of angle GEH and FEM. Okay, but they're opposite each other. Now, you may have a thought in your head that look at these guys right here. I'm going to do it in a different color, and I'm going to say 2. I'm going to put like 2 green marks. Those are also vertical angles to each other. So this angle here and this angle here are vertical to each other. Okay, the V here opens up, and this V here opens down. Whereas this V right here with the red guys opens to the left and to the right. That's actually a good way of thinking about it. Up, down, left, right. So it won't ever be these 2 guys here or these 2 guys here. They have to be opposite each other, opposite each other. You follow? Now, why am I bringing that up? Huge, huge thing. They're equal to each other. So red is equal to red, and green is equal to green. So when you have 2 lines that intersect at one point, they always form vertical angles that are equal to each other. Okay, so I really highly suggest that you write this down. I'm going to put it underneath the picture. So for example, angle GEH is equal to angle FEM. Those are the 2 red ones. Likewise, let's do the 2 green ones. Okay, if you want to pause me and write them and see if you got them in the right order, go right ahead and then unpause. Okay, so it would be GEF. You could call it FEG also, it doesn't matter, just as long as E is in the middle there, because that's the vertex. So we got GEF, and what do we have? HEM, or MEH is also fine. And remember, those are equal to each other. Ta-da, done. Good job.